Hello, Cool Kids family. I believe you guys are doing quite okay. Grade 12s, you are welcome. I am with you today, preparing for your March exam paper. All right, so we will be doing physical science today. We are going to revise on grade 11 Newtons, and we will be looking into the new topic organic molecules. Well, for some of you have dealt or have touched a little bit on it in your grade 11, but only a few of you. And to many of you, it's a total new topic. So just stick around so that we can see how to approach these two uh, topics in this lesson. Okay. So this question paper is obtained from Free State. It was written in 2022. This was the March paper, and it comprised of 10 marks. I mean, 100 marks. All right, imagine writing out of 10, by the way. All right, so I'm going to skip the multiple choice questions, and we are going to dive into our Newton. Then from there, we'll look into the chemistry, the organic molecules, these organic compounds. So let's go. Well, let's just check question 2. They said two crates A and B with masses of 8 kg and 5 kg were on stationary on the rough surface, and the crates were connected by a rope when the force of F with the magnitude of 8 Newton with an angle of 30 uh, was applied on the 8 kg block. So both blocks were moving to the right, and that's very important information. They were moving to the right. All right, so as you can see here, there's two blocks, and with the force of 80 Newton, and these two boxes were connected by a rope, uh, which in that rope there's a force known as a tension. As long as they said a light inextensible string, as long as they mention a string, you know that there is a tension force acting on the string. So they said now, state Newton's second law of motion in words. We learned this law last year in our grade 11. So even now it's still here. You just need to remember that law. I don't think at this point you forgot it. I believe you'll remember. You just have to know it. Okay, it said when a net force is applied on an object, the object will accelerate in the direction of the net force, and the acceleration is directly proportional to the masses. Right. So if you remember when I was explaining it last year, I said Newton was trying to say there is a reason why when you look at those mountains, they have never shifted before. Uh, they have never shifted before. This is because there is no force enough, or there hasn't been a force enough to shift those mountains. So, should we have a force that will be strong enough to shift the mountains, then the mountains will definitely shift. So, he also mentioned that, for example, should we have an object, I'm just going to use a soccer ball as an example. It will remain there until a certain someone, may it be player or not, but if that person is going to kick the ball, then the ball will go in the direction, will go in the direction of, uh, will go in the direction of the force. I hope you get the idea. So, in full, he said, well, the the object will remain at rest. This is the law. So I'm just going to explain it in a way that you will remember. He said, when a net force is applied on an object, the object accelerates in the direction of the net force. It means when you kick the ball, it will go in the direction of that uh, force. And he said acceleration is directly proportional to the net force and inversely proportional to the mass of the object. I hope you got that down. So let's continue. So now they said now draw a free body diagram. This is now 2.2. Draw a free body diagram for all the forces acting on the 5 kg block. And we know that since this is the block, there is a tension, and the tension is the one pulling the object. That is why the tension will go in that direction. And as long as the box is moving, then there will definitely be the friction force acting in the opposite direction, right? And then there will be a normal force, and there will be the weight. So when you draw, you just put a dot and you show the tension, the Fk, and the normal force and the weight. Okay, that's what you need. So remember, you will not, they didn't say draw the free body diagram for the 8 kg, but you will need it when you calculate or to form the formula. We'll get there when we have to calculate. So this is how you draw that box. So let's go and continue for the 2.3. They said the magnitude of the friction forces acting on plate A and B are 7 and 4.9 respectively. This is something that is very, very intriguing. If you check, they said A and B are 7 and 4 respectively. Think about this. When they said respectively, they are saying this is your A and this is your B, and you will have your 7.68 and your 4.9. So respectively means in Zulu, ngokulandelana. I just hope that is the right way. Ngokulandelana. Then in Spedi is kawalandelana. So you should start with the 7 and the 49. So they can't specifically say the B block had a friction force of 49. The A has the friction force of 7.68. They are just doing this just to reduce the longevity of the sentence. Okay, so be careful. Be careful. So now we know that the friction force on the 8 kg block will be 7.68 and the friction force of the 5 kg block will be 4.9. Okay, that's how you will remember it as. So the question is, calculate the magnitude of the acceleration of block B. So they want the magnitude of the acceleration of block B. Now, you ask yourself, why will they say the acceleration of block B? Why not A? It doesn't matter. They are connected. They will move at the same speed, isn't it? They will move at the same speed. We know we have to use the simultaneous equations because we have two blocks. If we are going to concentrate on the B block, then we cannot be able to find A, which is the acceleration. Let me show you what I mean. Before you start with this type of question, you need to remember your free body diagrams and form equations based on your free body diagrams. So I'm going to take you through the board, and we're going to work together, you and I. Let's go and check. Now, if you check, this is how our free body diagram looked like. We had a box, the 5 kg block, with the tension going in that way, and we had the friction force acting in the opposite direction to the object, which we know the normal force and the weight. Remember that we need to use that diagram to form an equation, and you are only going to concentrate on the horizontal forces, namely tension and the friction force, no any other force. These are vertical forces. So in Newton's second law, we don't work, especially that negative sign. So we're going to have MA. Then I don't have the tension. However, the friction force was given. If you remember, the friction force for the 5 kg block was 4,9. So I'm going to say 4,9 equal to MA. Oops, MA. Now that the tension appears with a positive sign, I advise that you immediately make tension the subject of the formula since it's positive. Then don't forget that your mass is 5 this time, multiplied by A, which is eventually 5A. Okay, then you'll have 5A plus 4,9. 5A plus 4,9. Now you have a tension and the A on the same equation. So you will need to find the second equation because this is now the spontaneous. So the second equation will be formed by the 8 kg block. All right, so let's go and look at the 8 kg block. The 8 kg block appeared to be something like that with their 80 Newton there with a certain angle. So we say, okay, should we draw a free body diagram? We will show the force, which is the force of applied, the friction force acting in the opposite direction to the object as long as it's moving. Not only that, we know that there will be a tension acting also in the opposite direction to that force. I will explain fully in a minute. And then we have our weight and we have our Newton. This is how your diagram will look like. Think about this. You have a box and a box, they're going in that direction, and then there is a force, and then suddenly you see tension going in that way and another tension going in that way. Yes, because this box is applying a force, on that tension so that this object goes in that direction. And at the same time, because of the mass of that object, this object is having some trouble. So it's as if the 5 kg block is trying to pull back and the 8 kg is trying to pull forward. You see, that is why it will appear as if now the tension forces are going in different directions. This is because this box is being pulled by that force on that rope, and now the 8 kg block, the tension also resists the movement of that. Think about when you're pulling something, you can see that you are applying more energy. The more you apply more energy, that means there's a force that is acting in the opposite direction to that power or that force you are pulling at. Hope it makes sense. So every time when you see the rope, they may bring some vehicles, some cars, you know that, okay, as long as another car is pulling another car, if the truck is going in that direction, then I know that the tension will act in the opposite direction to the direction of the force. However, on this one, the tension is the one pulling. I hope you get the part. So in that way, now that we have our diagram, we will say F net will be equal to MA. Now we have to break the F net into its component by using only the horizontal forces. Now say, why are you considering the F to be one of the horizontal forces? Hence, it looks like it's looking upwards. Well, if you remember in grade 11 when we were doing vectors, we said, should we have a vector that is acting on the x-axis, then it's going to the right. It's going to the right, so it's only part of the horizontal component. But should it be in the middle, then it will act as a horizontal component and as a vertical component. That is why we will consider it to be a horizontal component, and we are going to use a cos. So it's going to the right. Our applied force is going to the right. It will have a positive sign. And then now the FK is going to the left. We're going to give it a negative sign. The tension is going to the left. We're going to give it a negative sign. Then now the F applied, remember that there is a difference between a box being pulled in that way and a box being pulled at a certain angle. So when it is pulled at a certain angle, the force will multiply the angle, the cos theta. Please remember that. That is why we are going to say the force cos theta minus the friction force. Well, the friction force for that was 7,68, I believe you remember, minus the tension, which we don't have, and that is the 8 block. Then the force of applied was given as 80, so it's 80 cos theta minus 7,68 minus tension equal to 8A. All right, so let's go and take this number and put it in our calculators. So let's go and do that. We have 80 cos 30, right? Cos 30, and then we subtract 7,68, guys. Then we get 61,60. We get 61,60, right? Then minus tension equal to 8A, something like that. So what we are going to do now is this. Remember that this is now your equation number 2, right? This is your equation number 2. And we had 2 equations now. We had the first equation. This was equation number 1. Forgot to name it. Equation number 1. So now that we know what T is, let us simply just substitute equation 1 in equation number 2. That's how I recommend you do. Then as a result, if you check very carefully, I am now here. I have 61, sorry, 61,60 minus, now where the T is, I will substitute my T. So I will have 5A plus 4,9, then equal to 8A. Then I'm going to continue simplifying. I will have 61,60. Well, negative and that positive, I get negative 5A. Then again, negative 4,9 equal to 8A. Then I will have to group here. I will have to group. I have 8A that side. I'm taking my 5 that side. I have 5A. I will have 61,60 this side, and minus 4,9. And then in that case, if I say 61, 61,60 minus 4,9, I get 56,7. 6,7, and then 5 plus 8, I'll definitely get a 13A. Is it? Let's just confirm. You know how I don't like silly mistakes. So it's 13. So imagine getting it wrong just because you made the wrong sum. And then now you divide both sides by 13. Divide both sides by 13. Then your A will be, we take that 5, 6,7, 56,7. You divide by 13, you get 4,36. That is 4,36. 4,36. So therefore, the acceleration will be equal to 4,36 meter per second. Meter per second. This will be the end of your problem. This is how you're going to work out that problem. I believe you will review and make sure that you calculate correctly. I believe you will follow the same steps. All right. Perfect. All right. Let's go back to our problem. This is exactly what you are going to do then. So on our next problem, I'm going to leave a link on the description of this video. Please make sure that you click that link. It will take you to the page, to the lesson where we started discussing homologous series, the ketones, the haloalkanes, and everything. Okay, so let me just, before we do that, just going to show you what I'm talking about, because without them, you are not going to do anything. You are not going to do anything. So in that lesson, I discussed the meaning of these names, the types of homologous series. You must know what alkanes are, what alcohols are, and so on. So you must know their shape, you must know their suffix as well, how they end with, and how to draw them. So I covered those in that video. So now what we are going to do together is simply try to answer that question. Okay, so let's go and see. So now in this they said, well, it's question 5. The letters A to H in the diagram below represent 8 organic compounds. All right, that's cool. And then as we can see them as they are. And then they said, can you define the term saturated? Well, on that video, I covered that part. I covered the definition such as saturated compound. When we talk about a saturated compound, we talk about a compounds in which there are no multiple bonds. Okay, you will say compounds in which there are no multiple bonds between the carbons in the hydrogen chains. Okay, just go and study the thing. So basically what they're saying is when we talk about saturated, we talk about structures with single bonds, structures with single bonds. And then should we see a double bond like that one, as you can see, there's a double bond, then it's going to be unsaturated compound. So in other words, C will be an example of unsaturated compound, and this one will be an example. This one, number B, will be an example of a saturated because there are no multiple bonds. I believe it makes sense. So then they said, write down the following. The letter that represents an unsaturated compound. Well, I have just named it. I just told you guys. But look, this one is not going to be it because I just looked at the double bond. We need a double bond on the main chain. Should we have a double bond on the main chain, then we know that will be an example of unsaturated. So our answer to 5.2.1 will be a D, simply because there is a double bond between the main chain. This is the main chain, but the double bond is outside that main chain. That's why we are not going to consider this unsaturated. Okay, it will be another homologous series, right? Then they said, look at number B and give an IUPAC name. Let's go and look at it. Number B, where is it? There's number B. How are we going to name it, good people? First of all is to identify. Let me do this. First of all is to identify the main chain. So I'm going to write the name here. Is to identify the main chain. How do we multiply the main chain? Identify the main chain. Well, this is our main chain. How many carbons are there? 1, 2, 3, 4, 5, 6, 7. How do we call 7 carbons on the main chain? We learned about methane, ethane, propane, butane, pentane, hexane, heptane, octane. So we know that now we have heptane because it is 7. 1, 2, 3, 4, 5, 6, 7. So now we identified the main chain. Fine. And we can see there is a branch there. There is a methane, and there is a ethane, and there is another ethane there. So this is how we are going to name this. We are going to tell them that, remember we use the capital letters, right? We use capital letters, methane and ethane. Which one comes first? Well, we know ethane comes first in the alphabets. So on number, this one is gonna come first because it's ethane. It's 1, 2, 3, 4. Then we tell them that we're gonna write that answer here. Oops, should at least start here. Yep. Then we are going to tell them that on number 4, you say 4, you say there's an ethyl. You don't say ethane, it's just ethyl. On number 4, there is an ethyl. And on number 2, because we started from left to right, on number 2, sorry, it's 4. I mean, we start from the right to the left. Sorry, 1, 2, 3, 4. My apologies. So we start from right to left. I advise you start from left to right to left. So on number 2, there is, so you're gonna place another dash. On number 2, there is a methyl. On number 2 and also on number 1, 2, 3, 4, 5, and on number 5. So it will be 2 and 5 have the same methyls. So it's going to be 2 and 5. We have 2 of methyls. So we're going to use the word di, because di means 2. We're going to have di, methyl, di, methyl. Then we name the series. It will be heptane, dimethyl, heptane. This is how you name it. This is exactly how you will name it. Okay, so I believe you got it. Okay, let's continue. Then they said letter, like write down the letter that represents a functional isomer of an F. Remember that when we talk about a functional isomer, we talk about organic compounds that have the same molecular formula, same molecular formula, but different structure. We're going to look at F. Let's look at F. If you look at F, you will see something. You will see that this will be under carboxylic acid. This is under carboxylic acid. How do I know? Well, I know because the molecular formula of carboxylic acid end with COOH. Remember, you must cover that lesson. And we know that carboxylic acids goes together with esters. So listen carefully. The functional isomer of carboxylic structure will be an ester. No any other way. So how do we know an ester? We know it's an ester because of how it ends. The noid, that noid, we just want that noid, right? So it means to answer that 5.2.4, I mean 5.2.3, the functional isomer of this carboxylic acid will definitely be G. So the answer to that will be G. To that 5.2.3 to be G. You must make sure you cover that lesson. Then they said, name the functional group of compound C. We look at C and name the functional group of compound C. They just want the group. So what will be the group of that? Now I want you to look at it. And I want to remind you something from that lesson. You remember that after the alcohols, we will have something called aldehydes. Aldehydes. The aldehydes, it's when we have a double bond at the end of that carbon. Then from there we have a ketone. We have a ketone. So the ketone is the same as aldehyde in such a way that we only take the double bond. Suppose that this is what we have, three carbons, but then we can see that we have an oxygen at the end of the last C. So, but in the ketone, we try to place that O somewhere in the middle. Then this is how you know you are working with a ketone. Just like when we look at number C. So let me take you back to the document so that I can show you what I'm trying to talk about. I'm going to say organic. Right, let's look at this. You look at this table and you can see how the ketone look like. As I was saying, it will be somewhere in the middle, right? It will be somewhere in the middle. So let's go back. Let's quickly go back. So it's going to be a ketone there. It's going to be a ketone because of how it looks like. It's going to be a ketone, right? So let's continue. So the answer to that will be ketone. Oops, wrong color. Ketone. Then that's it. Then they said the general formula of the homologous series to which compound D belongs. They are talking about the general formula, which on that table you will study them as to which compound D belongs. So D belongs to, as we said, it belongs to the carboxyl acids. So the formula to it, because I can't take it back to the document, will be 2NH 2N. Please go and study those formulas. So you will watch that video because I want you to watch that video to learn them. All right, define the term homologous series. Well, homologous series is a series of organic compounds that can be described by the same general formula. Okay, this is just the definition of a homologous series. Then they said for compound E, to which homologous series does it belong? Let's go to E and see where it belongs. Well, it's going to belong to the alcohol. We know alcohols ends with the ol. Then it belongs to the alcohol. So the answer to this would be alcohol. Now write down the condensed structure formula. Then we're going to write a condensed structure. The condensed structure. You cannot draw the condensed structure unless you cannot write the condensed structure unless you draw. So let's look at that. Let's speak quickly. Our time is up. So let's just try to draw. Come on. This is how we draw. We know that it's pentane, so we have 5. C, 1, 2, 3, 4, 5. And we see that on number 2, there is an alcohol. Like on number 2, let's just place it here. There's an alcohol. So there's that OH there. And with all the hydrogens. So you start like this. This carbon has 3 H's, right? Has 3 H's. And the second carbon, this one has 2 H's. The third one has 2 H's. Now, the fourth one has only 1 H, which is found here, only 1 H, and in brackets, you will tell them that there is that OH. And the last carbon, which is that one, has 3 hydrogens. This is how you write a condensed structure, okay? That's how you do that, my good learners. All right. Well, if it's going to kick out, then is it primary alcohol? It's a secondary alcohol. We know it's a secondary alcohol because should I bring back my drawing, uh, the secondary alcohol means this carbon will be connected to the two carbons. The carbon that has an OH is connected to two. It becomes a tertiary when we see something like that carbon. It has another carbon there, and the OH here, and the carbon and the carbon. As you can see, this carbon will be connected to the three carbons. Then it will become a tertiary. It becomes a primary when it is at the end, like here, OH. This carbon will be connected to only one carbon. So our answer there will definitely be secondary alcohol. This is how we know it's a secondary alcohol. Explain your answer because the carbon is bonded to the two other carbons. Is the reason to answer that 5.4.4 because the carbon atom bonded to the hydrogen, to the hydroxyl is bonded to two other carbons. So I believe you got it, guys. So I will see you on the next lesson. Please make sure that you study this and you watch the video that I have recommended. Goodbye.